In this video, I want to show you a synthesis trick. Suppose you wanted to make this compound here, which is basically a bromide ortho to an ethyl group. So this would be bromoethyl 1,2 bromoethyl benzene. How could you make this? Well, you can see what the problem is right off. If you do your Friedel-Crafts to put on that ethyl group, followed by bromination, most of it's going to go para, not ortho. So that's not what you want. Put on the bromine first. It's also an ortho-para director. It actually deactivates a little bit. You might have trouble with the Friedel-Crafts, but if it goes, it's also going to go para, preferentially over the ortho. So we need a trick to get mainly ortho product. And so how are we going to do this? Well, let's just start with our benzene. Okay, here's some benzene, and we'll do the Friedel-Crafts reaction first. So aluminum trichloride. Okay, and then I draw in the ethyl chloride. Here's our ethyl chloride. Push the magic button, and there's our product. Now, if we do bromination, we'll get mainly ortho. We'll get mainly para, not ortho. Let me just do that to verify that that's the case. So here's the bromine, and I don't think this is going to work. It's not going to work. Oscar says, well, you get some of the compound you're looking for, but most of it is this guy down here. Now, if you're just doing this on a small scale and these are easy to separate, maybe this is good enough, but it's not very elegant. So let's try to do something else. So how can we make the ortho product become our main product? It's going to require more steps, but let's see what we can do. Now, what kind of a strategy can we use? This wants to add para preferentially, but what if it couldn't add a para? What would prevent it from adding para? Having something there else first. So let's get rid of the iron tribromide catalyst for now, and let's add something else to the para position. What are we going to add? Something that we can get rid of. What can we get rid of? Well, come down here to our menu. What we can get rid of is a sulfonic acid group. So choose your SO3 over sulfuric acid. This is the fuming sulfuric acid. And do this reaction. That sulfonic acid group is going to give you ortho and para, okay, just like we had before, and let me make it a little bit smaller. Here's the ortho and para, but now the para will be the major isomer, and if you play with this, it'd probably be a very predominant isomer because that ethyl has a bit of steric bulk. So there now we have something para to the ethyl group. So now if we do the bromination, come over here and get our iron bromide, okay, and we need our Br2. We do our bromination, and it's going to go ortho to the ethyl. Now, of course, ortho to the ethyl, this is not the compound we wanted because it's got that sulfonic acid group on it. But this is the beauty of the sulfonic acid, is you can get rid of it. You come down here and you don't use concentrated sulfuric acid, you use more dilute sulfuric acid and you heat it up. And if you do that and press the magic button, you should get the compound we want. Yep, there it is. So we've managed to successfully do our synthesis. So essentially what you're doing is using the sulfonic acid group as a protecting group for the para position. And put it on, do the reaction you want, and then take the sulfonic acid group off. So a fun game and a nice trick.